All right, one more push. Get error and make error with unexpected type. So the question is, do we want to synthesize this? Can I even accomplish what happens here with the lookups and stuff? I think I need to do... This is just all like compiler internal, the way I happen to have things implemented. So in order to look up the right version of make error, one of the return type, I can just go grab it and call the function inside it. Or I could try to construct like a syntax node that looks like this and let, you know, my existing code take over. I've already gotten the impl. So it could be as simple as that. I do have a synth function call. So I have synth parsed function call, which wants an AST node, and then it takes in, you know, the compiler takes over from there, which would be very, you know, robust, repeat a little bit of work. But the problem is here I don't have a parsed thing. Like what I need to pass in, the only thing I can really safely construct as just an AST node, because, you know, now we're in the problem of rendering the code back to almost text. So is a variable, because it's just like this single identifier. So as long as the thing I'm passing to this is just a variable, it would work. So I could probably do this if I do the get error call on a separate line, which means doing a block here. The other option is to just do it all in one go by grabbing the function. So by grabbing the function, that would just be like the block. The block's try impl. Well, it's got a full impl. I looked that up, and it just has a functions vector. So I would just grab out the function by name for that, and I know that it returns like the correct types. Maybe I'll just do that. So let's just try it. So let block make error. Cool. Sorry. Block try impl. So I could require it to be the first, or I could, let's find it by name. Set typed function call. Why does this thing take a, oh, right, no, it's, yeah. Ooh. That calls eval function call with the known stuff. It still looks up the function though, which is a problem. It still resolves it by name, but I know. So I would what I would need to synthesize might even be a typed call. Yeah. So my typed call, can I make one of these? A callee I can make. I'll make a static function callee. Arguments I have. Yeah. Oh, this is easy. Okay, so I'm going to make one of these, I think. And that's just going to be like this then. The callee is, well, I'm finding the function. Find f. And that's just an ID, so I need it by name. Oh, okay, we're gonna do it. It's gonna be okay, we'll get through and then we'll clean it up. Get function f name. The get error is different because I can just call that on the variable and it's just going to work. This one's weird because it requires the context. It would require the context to know what the expected type should be. So, I don't know. I'm going to put a big fat fix me. Like, consider alternatives for resolving the blocks make error function for calling the blocks make error function. In a less brittle way. Something like this. Oh, the argument is the error, which is the result of get error call. Just gonna unwrap him. Really? Do I have to do that? Yeah, I do. Really? Let's dereference it here. All right. Oh, because there's two do's. Ha ha ha. Oh, right. This got to be fully formed. The return type needs to be correct. Make error call. That's going to be the error type. And it's specifically the block error type in case there's ever subtyping, or in case I ever make subtyping better. Yeah, that's the type it needs to be. We need to be returning here. And span. And the sad thing is nothing is going to tell us if we've gotten this wrong except LLVM if we get lucky. Let's print it out. The if expr. Expr to string with type. Nice. Sorry, just looking for it, but it's below. Oh, because we're printing the whole block anyway. Well, whatever. Okay, we panic. Probably the identifier is not in the pool. 6591. Oh, it's probably not called make error. It's probably called make error underscore impl underscore specialized. That's why I shouldn't mangle the names. Okay, you know what? We're going to go into built-in. I'm going to make a note to just ourselves. Do not reorder. Ta-da! Okay, and that works. The if expr, producing result int string. Sorry. Let me just get back. So for this one, oh, and then I need the bool one. Oh, it works. Okay. So we should have a few of them. Yes, we do. So the if expr, if try for result i64 string dot is success, try value 686, try result i64 string get success. This is just get success, but it's which one? It's the one that we made when we implemented try for result i64 string. Okay. Otherwise, return try result i64 string make error. This one's easy because this was going to be the right type no matter what. Make error of try result i64 string get error. So get error i64 string. So what we should see in the next one is instead of try result, we should see try foo, right? In the make error, not on the make error, but on the get error and on the get success. But in the make error, since that needs to be returned, we should still see try result. So here is, all right, foo is success. That's right, because this thing is a foo. Well, let's look at the whole thing, right? So try value 687 is a foo. So foo is success, try value 87. Try foo get success, yes, get it out. Otherwise return try result i64 string make error, which wants a string. And we've checked that the error types match. And we extract the error using try foo from our foo. And that should be correct. So let's assert that this one can fail int. I swore I moved that up higher at some point. There they are. Returns 42. And let's make fails. Here's a function, result in error as well. And this one does a try that just makes a dot error. Okay, this is where maybe type inference might be good. Makes a dot error. Whoops. It's like, I don't know which enum type you want. That's because we're passing that none in. So let's go back to what we evaluate this guy. Let's do better here. So, okay. The whole block wants result in error. So inside of here, what I want, well, I could just say I want result in error. In reality, all I want is something that returns error. It implements try with an error type of error, but I couldn't use that to guide type inference anyway. So that's fine. We'll just do it this way. And here, what's interesting is it doesn't know what the success type should be. So this would really be much better with like let value. And this one's still not gonna know, which is kind of interesting. If I do this, will it say, yeah, now it does. So the way you'd probably write this would be more like this. And then we just say try value. Right. Which isn't returning the right thing because we're returning the int that we pull out. So let I, and then dot OK I is what we need to return. So if I just did I, no dice, which is good. But this should always fail. And then we're just going to assert right. Well, we could try fails. Just make sure that compiles. And from main, though, we don't actually want to throw. We could try it in a closure. So I could go I think it's like this. Let's see. It's going to be like closure must have explicit return type, right? So it's nothing. It's of type nothing to. Oh, can I do this? I don't think I can. No. I need to put it there. Closure returns incorrect type. Yeah, right. Let's try fails, and then just return I. Oh. And it returns okay, so it works. Okay, and then we're gonna call this. And I want to know what type res is. So I'm just going to say print res, and it's going to say expected string. It's a result I64 string. It is a result. So assert res is an error. Whoops. So let's move our closure case down because that's harder. And it is error whoops. And if we were checking for this, that fails on line 55. And if we said assert res is okay, whoops, it would say unrelated pattern type string will never match I64. Okay. Well, that's great. Again, I need to think of a syntax for this. And of course, these examples are silly. Here's a better one, right? Okay, that's a bug, right? We don't want to care about the success type, but with different types in the value. maybe that's just an old build. Now it's a bool. Yeah, that's fine. I don't know. What if I wanted to negate the bool? So my whole goal here is like, okay, why would I ever want the int out? Let's say I was checking if it was even, right? And then here, I want the bool out because I'm going to negate it rather than just unwrapping it and then putting it back in a result. It looks dumb. It's not really as good of a test. So that's that. It doesn't matter because it's failing. Okay. Let me try a blanket impl. So this is going to be I need names that don't collide. So I'm going to do success and failure. So I'm implementing result for result SF. No, I'm implementing try where T is success and E is F for result SF. I'm saying all results implement try, and this is how they do it, by simply constructing the variance by matching on self That's the one. And that works. So what if I didn't implement try for my special one? Oh, that's for foo. Yeah, that one needs it. What if we never implemented try for our specifics? We have a bug. Expected result SF, but got result I64 string. Okay, I thought that might be a bridge too far. That's okay. We'll fix it next time. Well, as always, thanks for watching.